Greetings to all. Welcome to VMware Administration Training. Srinivas here. Let's move on. Just before starting today's agenda, just explaining general information about this batch. VMware Administration, and it is going to already started on yesterday, and every day, Monday to Friday. Every week, 5 days, the live training session will be conducted. And Monday to Friday morning, 6 a.m. to 7 a.m. IST, 1 hour every day, Monday to Friday. There won't be any sessions on Saturday and Sunday. Yeah. This training is designed for 4 weeks. That means it is designed for 20 days, but it is going to take more days based on the explanation, based on the understanding of the content. It is not a problem. It is not restricted to complete this training within 4 weeks. Plus or minus will be there. Most of the time, we are going to extend 5 to 6 weeks. That means nearly 25 to 30 sessions will be there for this entire module to complete each and every topic and make sure you are going to understand that whatever the topics we are going to present. Yeah. This is general information about this training module. For any kind of queries related to payment, related to WhatsApp community or what course content or anything details, admin team is available. You can contact on mail or you can contact on provided numbers. This out of this 30 or 25 plus sessions, initial 5 sessions are free to attend, and that as soon as you complete the registration, this without payment, you are free to attend initial 5 live sessions. From sixth session onwards, a separate Zoom link will be shared to paid participants. Whoever completes the payment about this course, they are going to get a new Zoom link to join this training modules. That is going to happen from sixth session onwards. And once this batch, what is this batch information? How to get, you might are already part of WhatsApp community. If you are not part of WhatsApp community, just log into www.logiclabstech.com. Click on this www.logiclabstech.com. As soon as you log in, you are going to find information about upcoming batches. You just click on this upcoming batches information, wherein you are going to get a clear information about the batch details. We have been, Logic Labs have been providing different training modules in different time zones, like AWS, Azure, DevOps, Linux administration, VMware administration. Coming to this particular VMware administration, the batch number 244. So if you are not part of WhatsApp community, just select this batch number and you are going to find the WhatsApp link, and you can complete the registration link to join this initial 5 sessions. And once you are comfortable and ready to continue the sessions, you can complete the payment. That is a buy now. And if you want to details about course content or anything additional details you would like to get information, you can send a mail communication to support@logiclabstech.com and you can reach on this mentioned following numbers. I'm providing this WhatsApp community link on this chat window. If you are not part of WhatsApp community, please be part of WhatsApp, join the WhatsApp community. It is very much important to get a regular updates. Out of these 5 live sessions, first initial 3 sessions are going to upload, the recorded sessions will be uploaded to YouTube. that YouTube, once record is uploaded to YouTube, that recorded link will be available for your, you can share with your friends and you can review and all those things can be done. Initial 3 sessions are published to public. For all sessions, all the recording sessions, whatever the recording sessions are going to happen, all the sessions will be uploaded to LMS Graphy. This is a separate portal wherein you are going to, whoever completes the payment for this batch 244, VMware batch 244, wherein you are able to access these records from the day one to until completion of the session. Every record you can access anytime, anywhere, and this is going to be lifetime. You are going to get access for lifetime. Anytime you can play this video and you can download the record notes files, PPT files, and all those things. What are the files we are going to discuss? The running notes, I'm going to discuss this kind of running notes. We are going to upload these running notes to the same LMS Graphy portal, wherein you can download these running notes and then we can practice lab. Yeah. And very important point, while making the payment, you need to check that batch number. This is a batch 244, 244. No batch shifting is possible. Okay. If you have any queries related to payment or anything, you please contact at support@logiclabstech.com or you can reach on these numbers. Yeah. Admin team is available Monday to Saturday between 9 a.m. to 7 p.m. IST. Okay. This is a general information about this module. Let's move on. If you want to speak up, anyone would like to speak up, please raise your hand so that I'm allow you to unmute yourself, allow to speak up so you can ask questions. Yeah. I'm going to allow to everyone, whoever joined until now, I'm going to allow everyone to speak up. Anytime you can speak up by unmute yourself. Yeah, let's move on. What is this today's agenda? This is a day 2 session, live session. Today's agenda is what is hardware, voice, and application relation. It is very much important to understand this relation so that we are going to move forward. Let me explain, like each and every session is next sessions, what are the next session, upcoming sessions we are going to discuss. Every upcoming session is going to depend upon previous session. Whatever the topics we are going to discuss, that sessions is correlated, tightly coupled with each session. Okay, there is a requirement to explain each and every topic to understand upcoming sessions. Okay, this is a today's agenda. We are going to talk about all these topics. Let's move on. Before continuing, any doubts on previous session? If you have any doubts or any clarification, you are happy to discuss and you are happy to ask. Okay, I am ready to explain. Okay, let's move on. What is hardware voice application? How the resource sharing is happening? For example, this is a hardware layer. What is a hardware layer? We are going to talk about. Hardware layer is nothing but we are going to have a system. Whatever the system we are going to talk about, that is system consists of 5 major components. That is CPU, that processor, memory, that we are going to call it as a RAM, and storage. You are going to call it as a disk, and IO operations and all those things comes under this. And then you are going to talk about networking. Networking and this comes under IO operations. So this processor, memory, the disk and networking, these all components are going to connect on the motherboard. Okay. Why we need to understand this 5 component to proceed to move on? Because whatever the topic we are going to, whatever the training we are going to learn, that is VMware administration, that is virtualization layer. Virtualization layer is going to sit on this particular hardware. If you are not going to understand this particular hardware components, it is very difficult to understand what we are going to do with by using this virtualization layer. Okay. So generally, how this resource sharing, I'm using the laptop. A laptop is going to have an hardware components. I'm going to have a disk. I'm going to have a storage, CPU, memory. How the resource sharing is going to happen in my system? How the resource sharing is going to happen in my system? I'm going to open the task manager. If you see here, my system consists of number of applications running. What is this application? I'm using a browser, PowerPoint, Notepad, all those applications. What is happening here? What is happening here? These 4 components, CPU, memory, disk, and network. For each application, it is getting a resource assignment from hardware. Who's assigning this resource to each application? That resource assignment is done by the platform. What is the platform in my case? It is a operating system, that is Windows 10, Windows 11. That means by on the top of hardware, what I'm installing an operating system layer, that is it is playing a vital role. This operating system layer, it is going to sit on top of hardware. What is this operating system? This operating system is sharing the resources to applications. It is sharing the resources to application. Whatever the application you are going to execute, it is getting a resource from this particular hardware layer and sharing that resource. CPU, how much CPU required for each application to run, how much memory is required, how much disk space is required for each application. So everything is taken care by this operating system. Okay. Now in this virtualization layer, we are going to replace these applications, whatever the applications, we are going to replace with one more term called virtual machines. How we are going to get it, how we are going to deploy, how the resource sharing is going to happen. This operating system, till now we talk about Windows operating system, Windows 10, Windows 11 or Windows Server, whatever the operating system you are going to use. On top of operating system, you are going to install a number of applications. Each application is going to get a resource, CPU resource, memory resource, hardware, and network resources by coordinating with operating system. That operating system, that kernel, that is OS layer, that kernel is coordinating with the hardware and giving the sharing the resources to each and every application. That is a general behavior of a particular operating system. Why we are going to load operating system? Why we are loading an application? Because how many users are going to connect? In my laptop, I'm using only one user. I'm only one user. I'm using my laptop. I'm using multiple applications in the system. Okay. So according to user, how many users are going to connect? According to users, we are going to design what application to fulfill that user requirements. For example, IRCTC website, a ticketing website, booking the ticket, a railway ticket or bus ticket, what are the ticket you are going to, how many users are going to connect? Before going for how many users, now what is the difference between a desktop and a server? What is, we are going to have operating systems, a desktop operating system, server operating system. What is the basic difference in a desktop and server? Anyone? What is the basic difference between desktop and server? Yes, please. You are allowed to. You can unmute yourself and speak up.
Uh, Hello.
Yes, Ramchandra.
Sir, a server is a virtualized version of a desktop. Like server can be a virtual machine, and desktop is compulsorily a remote desktop, means at a user's local end. Server can be virtualized and accessible from anywhere.
Thanks, Ramchandra. But it is like a different version. Anyone? What is the difference between desktop and server? How we are going to qualify?
In the server, multi logins are will be there, and in the desktop, only single user will be login.
Thanks, Mother. Thanks for the update. Yes, desktop is a single user interface. Only one user can access the desktop application, what are the application. Whereas in if multi-user is different, multitasking is different. Okay. Now I'm talking about users. Number of users are going to access that application. Now I'm working on my desktop. I'm using Google Chrome. I'm using PPT. Only one user can use on this particular system, on this desktop. Other user cannot use my applications, what are the applications installed on my desktop. Why I'm going to saying the desktop? The operating system, whatever the operating system I'm using, that is Windows 10, Windows 11. It is a single user interface operating system. Whereas in server operating system, in the sense, multiple users are able to log in. Multi-user session is possible on server operating system. Okay. Now, how many users are going to log in? According to that, I need to design my platform. What is a platform? Operating system. Are you going to use for single user interface? You have to go with Windows OS or desktop OS. If you are going to use multiple users purpose, we have to choose an operating system which can support server. What is a server operating system? Red Hat is there, Windows to 2022, 2019, different operating systems are there. That is a classification. Now, operating system is designed to fulfill user requirements. The next, to load that operating system, I need to choose a hardware. I need to choose a hardware. What is the configuration I have to choose for desktop operating system? What is the hardware configuration I have to choose for server operating system? Okay. For desktop, for example, I'm using my laptop. I'm going to market. I need to purchase a hardware to load Windows 10. I'm going to choose a 4 GB memory or 8 GB memory, i5 processor or i7, i9 processor, and then I'm going to choose a model to make support that particular desktop operating system. If you are planning to purchase a server hardware configuration differs from the desktop operating system server. I cannot load a desktop operating system on a server. On a server operating system, I cannot load on hardware. So here, choosing a hardware for what operating system we are going to install. That hardware configuration matters here. As we are going to work on virtualization. Okay, till now, we discussed about only one server or one desktop. Going to purchase to install on Windows 22 or Red Hat server operating system. I need a hardware, CPU, how much CPU? I'm going to purchase a system. Now, virtualization. What is a virtualization? Why virtualization? Now, if you see my laptop, take an example of my laptop. What is the utilization? CPU, it is just consuming 20%. And memory, it is consuming just out of 16 GB, it is consuming only 6 GB. Like this, also it is consuming network, it is consuming some. That means I spent on this particular laptop hardware, I spent 1 lakh rupee to purchase this hardware and installing this desktop. But am I using optimal usage? That means I purchased the laptop to get use of this, whatever the resources are available. But I'm not utilizing. I'm wasting 80% of resources of CPU, nearly 60% of memory I'm wasting here. The disk space I'm not utilizing any much. So virtualization came into picture to effective utilization of resources. You are going to market to purchase a server hardware. The server, the desktop means it is comes with a 30,000 or 50,000. Whereas in server hardware, you need to spend lakh of rupees, 5 lakhs, 10 lakhs rupees. And you are going to purchase a hardware for to install an DB server or web server. Are you going to get optimal utilization? You spend 5 lakh rupee and purchasing one server. Are you in a position to get optimal utilization? That's there the concept comes in picture, virtualization. By using the same hardware, I'm able to deploy multiple servers or multiple desktops. By using 5 lakh only one server, I'm going to deploy 10 servers or 50 desktops can be deployed on the same hardware to utilize this underlying hardware resources. That is why we need a virtualization. Effective utilization of resources. To understand effective utilization of resources, this operating system, whatever the operating system we are going to talk about till now, we are going to use the same hardware. On top of it hardware, we are going to use the virtualization layer as an operating system. On top of, by using this virtualization layer, we are going to deploy multiple virtual systems. To load an operating system, I need a system. To load an operating system, I need a system. If the operating system is available, then only I can install application, either DB application or web application, whatever the application I'm planning to install, I need a platform. To install that platform, that operating system, I need a system. A system is nothing but consists of 5 major components. What is that? CPU, memory, storage, network. These 4 components are going to connect on the motherboard. Any clarification on this? Any doubts? At any moment, if you are not clear, try to understand this physical environment, because virtualization, it is imagination. If you are not able to correlate the physical infrastructure, not able to understand the physical infrastructure, you cannot imagine what is a CPU, virtual CPU you are going to call it as. If you don't understand physical CPU, you cannot imagine what is a virtual CPU. You can, if you are not able to understand what is a memory module, how it looks like, you cannot imagine how the memory, how I'm assigning the same thing. So I'm going to discuss about the physical 5 major components. What is a motherboard? What is a server model? And all those things I'm going to discuss about. Now, I'm talking about motherboard. In this motherboard, you are able to see few components. Out of few components, we need to understand 2 major components. on this motherboard. One is a processor and second one is memory. Where we are going to install the processor and where we are going to install memory. Why we need to understand? As the virtualization, why we are using virtualization? To deploy multiple desktops or multiple servers by on same hardware. That means multiple servers I am deploying on the same hardware. How much capable that hardware should be? I need to make sure whatever the hardware I'm using for virtualization, that should have enough resources to support my multiple deployments, multiple virtual servers. Now, who is going to say what are processor, where I'm going to install processor, where I'm going to install memory? Anyone? You can unmute yourself. How I'm going to get this information? You are no need to go directly look at this. The only thing is that we need to understand whatever the server we are going to discuss about. For example, Dell PowerEdge, I said. Dell PowerEdge, we have Dell PowerEdge R820. That is one of the model we are going to use in our lab. The specifications we are going to get. There's some specifications. We can mention specs. By understanding the specs, we are going to get an idea how much configuration. We need to understand by looking at this configuration, what is the configuration. See here, just I'm going to increase. Okay, now see here, what you are going to understand. By looking at this information, the specs of this particular server, I need to imagine this particular design. Who is going to understand, who is going to say, by looking at this document information, which processor, which motherboard is suitable this configuration? Anyone? We are not going to see a physical server which is sitting in a data center. I am sitting in my home or in my office. I should able to get information about only the server model. I'm going to get only server model. By looking at that server model, I need to understand how many processor can be installed on this particular hardware, how much memory I'm going to get, how much disk I can configure, how much network interfaces I can install. This is an important information we need to understand to proceed with virtualization. Can anyone able to understand? If no one, I am going to proceed. Yeah. See here. In this motherboard, the square one, the square, whatever the square is there, that is we are going to say that socket. That is where we are going to install the processor chip. Whatever the processor chip we are going to install, that processor chip is going to come and insert in this particular square socket. This square one we are going to call it as socket. Now I'm going to refer in this motherboard how many sockets are there. This is 2 sockets are there. That means how many processors I can install? Only 2 processors I can install. Because as a virtualization administrator, I need to understand hardware configuration. Why? I'm going to deploy multiple servers, multiple desktops on by using virtualization layer. So underneath hardware infrastructure should capable to support those many servers, those many desktops. Okay. So coming back to this, I'm going to refer that server model. I'm going to understand which motherboard is suitable as per specification of this particular configuration. See here, Dell PowerEdge R820. How many sockets? Processor sockets 4. That means whatever the discussion I am showing here, whatever the visualization I am showing here, out of these two motherboards, R820 is going to have this kind of motherboard that has 4 sockets. That is going to have 4 sockets. That's what in this model I can understand. That means by looking at this processor sockets 4, that means the motherboard has a 4 sockets. That means I can install 4 processors. What is the processors can be installed on this socket? This is the Intel Xeon processor E5 or E546 version. What is this processor? This is a chip, and we are going to understand that chip. First understand the socket. So we understand that motherboard has a 4 sockets. The next one, important thing, memory. See here, up to 3 TB of memory it is going to support. That means how many DIMMs are there? What is the terminology it is using? Slots. What is the slots on this picture, on this motherboard? Whatever the rectangular things are there, white and black combination, here blue and black combination, those are called DIMM slots. I'm calling this processor as a socket, and this ones I'm going to call it as a slots, DIMM slots. That is a memory module. That is a memory module we are going to install on this particular slots. How many slots are there? How many slots are there as per specification? How many slots are there? 48 slots are there on this particular server model. 48 slots are there. What is the configuration I'm going to get achieved? It is going to support until 3 TB by installing 2 GB module, 4 GB module, 8 GB module. These modules are going to support. The memory modules are going to have, this is the memory modules. These kind of memory modules are going to sit and insert on that particular slots, and that getting what is it each one. If I install all 48 with each DIMM with a 2 GB configuration, 48 into 2, 96 GB I'm going to achieve from the server. I'm going to achieve 96 GB. If I install all the modules as per this configuration, if I install all 48 modules with 64 GB configuration, 48 into 64 GB, I'm going to achieve 3 TB of memory. A server or configuration are going to support these two major components. Processor, how much processors can be installed on the motherboard? How much memory can be achieved on this motherboard? Based on these two processor and memory configuration, I am going to design my virtualization layer to deploy multiple servers. Okay, multiple servers or multiple desktop operating systems. Either I'm going to install desktop operating system or server operating system. I need a hardware. That hardware I'm going to give by using virtualization layer. That hardware I'm giving to virtualize that imagination. So to create imagination, we need to understand this processor, how it looks like. This is a physical processor. That physical processor are going to insert on this particular mother wherever that socket is available. Okay, so we discussed about motherboard, understanding the socket, understanding the slot, where we are going to install processor, where we are going to install memory module. Any clarification on these two components? Total 3 components were discussed. Understanding of motherboard, understanding of the socket, understanding of the slot. Why we need to understand? Because As a virtualization administrator, we have to choose a hardware which can provide the maximum resources, so that by using this hardware resources, I am going to deploy how many servers, how many desktops I can design, I can deploy. If underneath hardware is not having sufficient resources, I cannot deploy multiple servers. Now, coming back to an understanding, my laptop is there. What is a CPU? What is a memory? Only talking about memory. My memory is a 16 GB. I'm going to use the same system to install virtualization layer. By using 16 GB, how many desktops I can deploy, how many servers I'm going to deploy. Desktop operating system minimum requirement is 2 GB. That means by using this 16 GB, how many desktops I can configure with 2 GB memory? I can deploy only 8 desktops. Coming to the server, the minimum configuration, server configuration is 8 GB or 4 GB. If take it as example, 4 GB. How many servers I can deploy? By using this 16 GB memory, I can deploy only 4 servers, right? This is the understanding of hardware resources. Why we need to understand? We are going to deploy by using virtualization layer. We are going to deploy multiple servers, multiple virtual servers, multiple virtual desktops. How many desktops I can deploy on the same hardware? How many servers I can deploy same hardware? We need to understand available resources. How many CPU, how much memory is available. Clear? Any doubt? That's what we discussed. First, understanding hardware, OS, and application. How this application resource sharing concepts is working. That's what we explained. Hardware resources are managed by operating system. That operating system is going to assign resources to respect to each and every application. Now we are talking about system and server components. That's what we discussed now, system and server components. In this particular system and server components, we just discussed about this motherboard processor. Now in this processor, we need to understand one more important thing, that terminology. What is the terminology? Who can say that? Who can come? We are going to say that quad core, dual core, octa core. While you are defining your mobile configuration, my mobile has a octa-core processor. My mobile is capable of quad-core processor. What is the dual quad and octa-core processor? Can anyone? What is the dual quad-core octa-core processor? Can anyone? What is the terminology dual quad octa?
Sir, total number of cores that are present.
Exactly. For example, dual core in the sense, thank Ramchandra. Dual core in the sense, the physical process, whatever the processor you are looking at here, the processor, the physical is going to have only one, but it is capable to perform two actions at a given second. What is a quad core? Quad core is nothing but a same single physical chip is capable to perform 4 actions in a given second. Now we are going to experience how the processor configuration. I'm going to go to intel.com and we are going to understand the processor products. The process mod family is available. See here, Intel Xeon. Intel Core, Intel Atom. We are going to discuss about server processor. That server processor is talk about Intel Xeon, Intel Core, i5, i6, i7, i9, i10, all those desktop processors. Now, as soon as you click on Intel Xeon, you can see the processor, different families processors. We need to understand here. See here, how many cores? This is going to be a single chip. This is going to be Intel Xeon single chip. It is a physical processor where we are going to insert on the motherboard on the socket. That processor is going to insert there, a physical processor. Try to understand. Physical processor is insert. As per this configuration, how many cores it can support? That means one physical chip, it is only one chip, one processor, but it is going to perform 32 instructions per a given second. 32 instructions per a given second. That is what we are going to call it as a number of cores, virtual cores, logical cores. Sorry, what is it? This is a physical processor. I'm going to call it as. This processor is capable of 32 cores. Now I'm going to derive a configuration. Now how many sockets are there? 4 sockets are there. Now I'm going to install the same processor, 4 CPUs. I'm going to install in 4 sockets. That means 4 into 4, I'm going to get total how many? 16, right? Now, but logically, each processor supports how many? 4 into 32. That means I'm going to get a how much capacity I'm going to get CPU cycles? 4 into 32, 128. 128 chip logical cores I'm going to get by using the 4 sockets on this motherboard. By using 4 physical chips, I'm going to get to my virtualization layer operating system. I'm going to get 128 CPUs, 128 logical cores. Okay, is it clear? There is another motherboard. There is has a 2 sockets. By looking at the 2 sockets, I can install. I'm going to get a 2 into 2 only 4. But the same Xeon family processor I'm going to purchase, I'm going to install, and I'm going to install. Each processor is capable to deliver 32 logical cores. So I'm going to get 64 logical cores. This is what we need to understand. What is the capacity, CPU and memory capacity from the same hardware? We are going to give the resources. Virtualization layer, what it is going to do? It is going to give the resource sharing, CPU, assigning CPU to one virtual machine. Memory, some memory assigned to one virtual machine. That virtualization layer is giving resources, sharing the resources to whatever the servers we are going to deploy, virtual systems. Okay, why we need to understand? Core, it is not a core, logical core. First we understood that socket. After socket we understood the core, then logical core. Now the one more terminology called hyper threading. What is hyper threading? Anyone? Hyper threading. What is hyper threading? See here in the same CPU family, what it is mentioned? 32 cores. But at the same time, it is going to mention number of threads it is going to support. Each family, each server processor, how many threads it can support. See here, total threads. Actual cores is 32. The total threads it is going to support 64. Each and every motherboard has a program called BIOS, basic input output system. On this BIOS configuration, by default, hyper-threading is enabled. And whatever the processor we are, server family processor or desktop processor, we are going to get Intel by default, hyper-threading is enabled. That means what is I'm going to get here 128 processor as per the CPU. As soon as I'm inserting the processor on that particular motherboard has a capable to enhance the performance by enabling hyper-threading. That hyper-threading, as soon as you enable hyper-threading, and you are going to get how much processors we are going to get, total logical cores. That 128 is going to be double. 128 is going to be double. That means 256 logical processors I'm going to get. Where I'm coming from socket, I'm started, and then understanding cores, how many sockets into physical processor. Each physical processor supports 32. I'm going to get 128. On the motherboard, we are inserting that particular processor. If that motherboard has a capable to understand hyper-threading, then automatically this 128 logical cores becomes 256. Here, how much it is going to come? If that motherboard support hyper-threading, this current is going to come 128 logical processors. Why we are going to talk about resources, compute resources, CPU and memory. This is where I need a max performance to share the resources to my virtualization layer. Okay, so under processor, what we need to understand? Core, logical core, hyperthreading. These three terminologies are important under processor. Okay, any doubt, any clarification? Now, server types. We are going to talk about virtualization. When we talk about virtualization, we need to understand what type of server models are available. What type of server models are available? Tower server, rack server, blade servers. Without understanding specifications, we are not clear. Okay. Second thing is that without understanding hardware, what is a server? Is it a tower server? Is it a rack server? Is it blade server? This every organization, enterprise organization, large enterprise, mid-scale, large-scale enterprise organizations are there. According to their capability, according to their requirement, they are going to purchase these servers. Most of the enterprise environments, large-scale enterprise environments, are using currently the blade infrastructure, blade server infrastructure. This blade server infrastructure in use for virtualization layer. What is this blade infrastructure is going to capable? What is a rack server it is going to capable? Okay, we are going to just overview about this server model. What server type is going to support what? Okay, for example, what is a rack server? Why we are going to call it as a rack server? If you see here, rack enclosure. This is a typical rack enclosures in your data center, which will be there. This is a rack wherein this rack server will be rack enclosure will be placed in the data center. In this particular rack enclosure, whatever the rack servers, 1U rack server, 2U rack server, 4U rack server will be inserted in that particular rack enclosure. This is a data center, that rack enclosure. It is a just like iron safe, iron enclosure. In this enclosure, as a provision to place our servers, and it has a provision to connect power supply, to connect network cables, to connect storage cables and all those things. This is a rack enclosure wherein we are going to insert our rack servers. Why we need to understand? As as a VMware administrator, you are going to work on physical infrastructure. A Windows administrator or Linux administrator is going to work on either physical server or virtual server. But as a VMware administrator, you are going to work on only physical infrastructure. By using the physical infrastructure, you are going to deploy virtual servers and give it to Windows admin or Linux admin. A Windows admin can become as a virtualization administrator so that he can everything he can deploy, everything he can manage. Industry, every industry organization is looking for a IT specialist which are having a multiple skill sets like managing the server operating system, managing the virtualization layer, managing the cloud infrastructure. It is not restricted. The IT is evaluating. We need to understand how this virtualization is going to work. If you understand virtualization layer, how it is going to work, you are in a position to understand how the cloud infrastructure is going to come into picture, how it is going to work. Okay. So this rack enclosure, this particular. Now next one is blade chassis. This is a enterprise, large-scale enterprise environments are using this blade chassis. What is this blade chassis? If you see here, this blade chassis is capable. This again, this one chassis is going to come and sit in this rack. How many chassis are going to sit? For example, I'm using rack servers. How many rack servers I can insert? Only maybe one U rack server. That is one U rack server means this is a one U rack server. These kind of servers I can insert in the same rack. In the same rack, I can insert maybe 10 or maybe max 15. 15 servers I can insert in this particular same rack. Now, I'm going to insert this blade chassis in the same rack. 4 chassis I can insert. 4 chassis. 4 blade chassis I can insert in the same rack. But the beauty of this blade chassis is each chassis can accommodate 16 blade servers of height blade server. There is a blade infrastructure is available. See here, this is half height. This is a full height. What is the difference between half height and full height? Full height has a bigger motherboard wherein it can accommodate number of memory slots, number of processor sockets. Whereas in half height, it is going to get the total resources half of the full height. This full height is going to accommodate maximum CPU, maximum memory resource. Okay, these blade servers are designed for compute resources. What is compute resources? Compute resources are nothing but processor and memory. This particular server is going to have only 2 storage disks to install operating system. Most of the configuration supports max CPU, providing max CPU, max memory. Whereas in tower server, it is designed to use for storage applications. Because why? Because it can accommodate maximum disk base to connect, maximum hard disk to connect. Whereas in 4U rack server also, it is going to have multiple base to insert storage. And at the same time, it is going to have certain memory slots, certain process sockets. So that according to our application requirement, am I using storage application? I have to use tower server or 4U rack server. Am I going to use for virtualization layer? I need only compute resource. So I'm going to use half height blade or full height blade. Okay, this is understanding the server hardware model. Okay. Most of the enterprise environments who are working on virtualization, they go for blade or infrastructure. That means imagine this particular chassis can accommodate 16 blade off height blade. If it is a full height, only 8 servers can be installed. 8 into 4. In the same rack, I can install 4 chassis. Those many servers I can place in one rack. A big data center is going to have these many servers are placed on that particular data center, and they are going to manage all this infrastructure in redundancy manner. Okay. As a VMware administrator, we need to understand this physical infrastructure. Without understanding physical infrastructure, what is a processor, what is a socket, what is a server model, without having any idea, you are not in position to work on virtualization. Any questions on this particular topics until what are the topics we discussed? Any questions? Now we have a lab service. What is a lab service? We said Dell PowerEdge R820, R630. Those are rack servers. Those two rack servers are sit in this particular rack enclosure. Okay, so they are in my data center, in our data center. So we are connecting those two rack servers and we are going to do our practicals. Okay, lab access. Until this, any questions?
Sir, HP also provides that.
Sorry?
Sir, HP also provide blade server. Sir.
Yes,
HP also provide blade server.
Yes, HP enclosure is HP chassis is there, blade chassis is there, Cisco is there, Cisco, Lenovo, IBM blade chassis is there. Every vendor supports
Sir,
their infrastructure.
Sir, actually, sir, HP service is blade service is like a server working and divided into according to memory utilization. Right, sir?
Please come again.
Sir, blade server is a server divided by the according to memory utilization.
Not memory utilization. We are talking about server model. What server model we need to choose for our virtualization? What server model? We need a, for virtualization, we need a compute resources. What is a compute resources? Processor and memory. Where I am going to get a max memory, where I am going to get a max processor capacity. Do I need to choose a tower model? Or do I need to choose one U rack server or two U rack server? It is all depends upon what is the compute capacity. The blade infrastructure, why we are using the blade infrastructure is intelligent enough. It is going to swap the hardware on the fly. It is going to swap the hardware on the fly. For example, one of the blade server had having a hardware issue. Automatically it is going to swap that operating system to another blade infrastructure. Redundancy, it very high intelligent enough to swap that hub, maintenance, make sure that it is not going to fail any single point of failure. Profile configuration, swapping, a simple deployment. Many features are available in Cisco, HP blade infrastructure, Lenovo blade infrastructure. Virtualization, because it's virtualization is not a single server. Virtualization means each server is going to support 50 to 100 servers, one particular server. If that particular hardware is down, 100 servers are going to down. So we need to manage that high infrastructure, high capable resources in our virtualization infrastructure. Okay.
Hello, sir.
Yes, please.
Sir, when we are going to set up this home lab setup, so we are going to use which type of server?
Home lab setup, we are going to use VMware workstation. I'm going to explain at the end of the sessions. No worries. First, we complete the lab on this particular Dell PowerEdge servers, because home lab is just to practice how to install and how to do practicals. But a real environment, you are going to understand the physical infrastructure. Okay, you need to talk about the models. Whenever you are going to face interview, you need to talk about what is the server models, what is your inventory. You need to talk about this blade servers. You need to talk about rack servers. Okay, I worked on this rack server. Our environment is installed on this rack server. Like that, you need to talk about. Okay.
Sir, and the two servers you are going to provide means the only that two particular servers will be accessed by all of our students, or
Yes, those two servers we are going to assign all of the students who are going to complete the payment. We are going to assign the login credentials. They are capable enough to extend all the configuration. Each server has a max memory, max CPU configuration. We can complete the entire lab with that resources.
okay.
Okay, that is all for today's session. If no other questions, we are good to close. Please go to the site and please go and complete the payment to continue uninterrupted sessions, live sessions. Yeah. Thanks for all your participation. Have a great day. Thank you all. Bye.